Well, I'd like to demonstrate the use of these various coordinate systems in landscape CAD drawings by working with this very simple little design for the rear of a small house. So there's a footprint of the house there in red. And let's imagine that we were doing a survey and there's already some screening across the back, and there's an area for, let's say, a vegetable plot there, and we want to locate that vegetable plot accurately. So let's now remove it. We might well have measured its dimensions because it might well be defined by some hardwood edging, so we know its dimensions. Let's say it's 6 metres wide by 4.5 metres in height. So let's erase it. How do we accurately plot that rectangle so that it sits properly on the site? Well, we may well have, if I pick the line command, we may well have measured a line from the end there in this direction perpendicular to the house, and we may well have measured that that was 3,000 units away from the house. So we've picked up the pair of Cartesian coordinates at the end of the house. Let's actually demonstrate that by going to Tools and ID Location. We'll snap to the corner of the house there, and you may be able to see down here in the command area that the X value is minus 4459 and Y is 3198, and there are a few decimal places. So that we know the Cartesian coordinates of the corner of the house in this particular drawing. But it's not of any great value to us when we're trying to locate that rectangular area. We can't just type those long and complex pairs of Cartesian coordinates. How do we locate the rectangle? So we'll pick a line, and we can easily snap to or locate there. And with polar turned on, I can just say, well, we've measured that length. It's 3,000. I just type it. In goes a line, and I'll right-click and exit. That's in a sense a construction line. So now I can set a rectangle starting at the end of that construction line. So it's draw, rectangle, 2 points. I can again snap to the end. That will pick up the Cartesian coordinates of the corner of what will be the vegetable plot. Now we've measured the plot. We know it's 6 metres wide by 4.5 metres high, or 6,000 by 4,500. So we now start to use polar coordinates, relative coordinates, and we use the @ sign and type 6,000. We're going to go 6,000 in the X, a comma, 4,500 in the Y, and hit enter. So in goes the correctly and accurately placed rectangle representing what will be the vegetable plot, and then we can select that line and erase it. So we've used a combination of, we actually haven't used the Cartesian coordinates. We picked up the location just by snapping to a line, and then we've used our relative coordinate system to accurately plot that rectangle in place. Well, suppose on site there was a screening wall running at an angle some distance away from the vegetable plot. You've measured this little distance here, and it's 750. You can determine that on site. And you've measured the length of this. We'll say it's 5,500 or 5.5 metres screening wall. You're not too sure of the angle, but on site it looks to be close to a 45-degree angle. So let's see if we can draw those two lines accurately using these mixture of coordinate systems. So it's draw, line. We can pick up, we don't need to type pairs of coordinates, we can pick up the start point there. But now we know we need to go horizontally, 750. We could just type 750 with polar on, and that would get us there. But I want to show you that you can say at 750 and use the caret sign and type 0. So it's going to draw a line 750 mil long at 0 angle. Now we're going to head off in this direction here. I'll take polar off just for the moment, so the line can go in any direction we want. So we say at the distance, we've measured the screen to be 5500 and the angle we've estimated to be 45, and right click and exit. So we can now remove the construction lines that are there. There's a magenta line on top of a cyan line, but the screen wall is now in position. We might have measured its width, it might be 110 mil, so we can simply say modify and offset, pick that line and right click and set an offset distance, say of 110 units, and then pick a side. So we'll exit from there. So that's our screening wall being located accurately. So we're trying to use this mixture of different ways of locating entities just by mixing our coordinate systems, but all the time every one of these entities has a pair of Cartesian coordinates under it. You don't normally need to worry about them. It's much more common to be using relative coordinate systems and polar coordinate systems, as we've demonstrated here.